I haven't posted a video in a long time, so I figured I'd catch up finally. I've been busy winterizing the garage slash shop, um, so I can continue throughout the winter time to build and not just be forced into the hobby room upstairs like last year and the year before that. So the upgrades I've done is closed the ceiling, insulated it, and put a wood burner stove in, so it keeps it nice and warm in here. That I have no problem working out here for an extended period of time. So I like that. And I'm milling different things, testing its limits, and the verdict is overall satisfied for what its intention was, and it will do anything with aluminum. I've done really thick stuff. It's cut it out with no problem. Bearing holders. Very accurate. And once you tune it in, and motorcycle parts. Oh, there you go. So yeah, I've been busy. Well, what I've learned is my limitation is caused by the lack of mass, for one thing. The bed I'm using is it's a half-inch cast aluminum, but it only weighs 5-6 pounds. It's not that heavy. I can't keep down the chatter that I need it to keep as far as milling steel, not aluminum. Aluminum's fine, but and that's kind of what I was shooting for in making it as stable as I did, was to be able to mill mild steel and stainless. So yeah, the weight of the bed is a problem. The fact that it doesn't have any T-slots in it makes clamping to it difficult. The cutter I'm using is essentially a trim router. It's a quarter horse, and it does very well. And then for aluminum, using for T3 aluminum, I would use a 2-flute because it tends to clog. It's a softer aluminum. At T6, I can use 4-flute, and it rips through it like there's no tomorrow. I have no problem with it, especially with the flood coolant. But as soon as I put steel in it, I get resonance. It just seems to work awfully hard. The speed is much too high for steel. 31,000 RPM. That's no load, but still, that's way too fast. And there's nothing I can do about it. I can't go from 2 to 1 flute. That doesn't solve the problem. It's too fast, and the head with the cutter also doesn't have the required mass to stay firm and absorb that resonance, and regulating the RPMs does nothing for this setup, because it's an AC motor. And while they do sell them, I'm sure you've seen these on eBay and everywhere else, this will regulate it, but as soon as I turn it down, I lose not only RPMs, but I lose torque. So much torque, in fact, that it renders it pointless. Where there's so little torque by the time I get it down to the RPM range that I want, that it bogs it down and stops it. So these are the problems I've been dealing with, and I've been going over and over and how to solve it. And the only thing I can come up with is make it heavier and go with another motor, one that I can regulate, that doesn't have a high RPM, and that allows me to regulate it and still provide torque. And this is what I'm working on now. Also built another station, because large projects have sub-projects, and you can quickly get into such a mess that you can't find anything. This is This is his big brother. This is all steel. It's a 1/2-inch steel plate. I molded it down on a steel base out of C-channel, heavy. Yeah, it is solid and it is heavy. This design is kind of wacky, but it feels right, so I'm going to do it this way. My y-axis, I milled a slit here. My servo is going to be back here underneath. It's going to drive a ball screw assembly connected to a plate that will come through here and move my y-axis. And on the plate that goes on here, this will rest. This is my x-axis, and this is butter smooth. The bearings are just so smooth, but it'll give me much more travel now. This plate, this is cast iron. It weighs about 40 pounds. Doesn't look like it, but it is heavy. Has T-slots. I got it really cheap. There was a problem with the surface, and a buddy at work took care of it for me and resurfaced it for me, so it's perfectly flat. And yeah, this will be going then on the plate, giving me my X and Y axis. Where this thing is resting, a tower will come up and forward. That tower is underway. It's almost done. I just need to do this and this surface here, and it'll be good to go. It's also a 1/2-inch plate. I have the two pieces clamped together, so I'm milling it as one, so they're accurate to each other. And it will be here, come up, and mounted on it is a spindle. I kind of fudged one together myself. I'm using well, originally for my upgrade I was going to use an extension shaft like this. This is actually what I started with, because it gives me a collet and it gives me a straight shaft. The straight shaft gives me a spindle with bearings, and then I can drive it with a motor. But looking at it, I thought, well, you know, why don't you just overdo it a little bit? They make them a lot bigger than that. I'd rather overdo it than underdo it, so I went with a 3/4 inch shaft, C20. But it still has right now it has an 1/8 inch collet in it. That's what I use mostly anyhow. But it has so much more mass. It is, I mean, the shaft is heavy, the body is heavy. This is a what do they call it? Pillow block bearing with lock and collet. I just slipped the shaft into it here, made a body for it. Here it comes out again, lock and collar. My problem with this setup was getting the 3/4 inch shaft from this collet to mesh up with this. It has this shaft is an 8mm shaft going to 3/4, but it did have threading on the inside of the shaft of the collet. So I needed something with this thread that would have on the other side an 1/8 inch or an 8mm shaft. So I came up with this, out of desperation, this setup where I put the bolt in and tightened it down, and then ran it forward with the Dremel and ground the head until it mic'd out at 8mm, and it worked out perfect. so I got a kick out of that. The benefits, besides the obvious that it's heavier, has much more mass, is also that I have a DC motor now. It's a permanent magnet DC motor. It's double the horsepower. It's half horsepower, and it can be regulated from very, very slow to max it out and retain that torque that I so desperately need to push through steel. I'm driving it with a Japanese power supply, 50 amp, 12 volt, and a PWM controller board that can handle 2000 watts. Right now I'm using a potentiometer to adjust it, but later on my driver board for the servos will be driving it. So I can, within the program, tell it what RPM to run at. And another big plus for me is it's almost dead silent. Listening to the router scream for hours on end, that really got on my nerves. This is, as you can see, almost dead silent. And I can run it this slow with no problems whatsoever. And even at this slow speed, it has quite a bit of torque. You know, I can't stop it. And yeah, this puppy's just getting warmed up. So I kind of went out on a limb. It sounded good in theory, but I was, well, I figured even if it went south, it would be a good experience. But I'm very pleased with the way it turned out. The mounts are I made on the other CNC machine. They turned out really good. So that's where I'm at. Staying busy. And as soon as I get the tower done for the Z-axis and get the bearings set up for that, I'll post another video and hopefully get this thing running within the next month. I can't wait. I think this is it. This is the one. This is the one I've been looking for. I think this will be able to do everything. So, and if not, well, then I learned something else. All right. Thanks for watching.